Hello and welcome back. Today I want to talk about hard and soft links. So I'm in the Tux users home directory and I'm going to list the inode numbers of all of the files, and then inodes will keep track of file attributes and where the file is in the file system, so the disk block location of the file's data. So I'm going to use this next command, long listing directory inode number human readable, and I can see the link count here is 22. So let's take a look inside of the directory here, and I want to use the word count command to count how many lines we have here, how many new lines we have here. So this counts 21 of these file entries. However, if we look in the mydir2 directory, it has a subdirectory, and so that would make 22. So this is the link count of the home tux directory, and this counts how many links it has to all of the files that are found underneath it and the directories. So let me just clear the screen. That's just something to remember when you look at the link count of a directory. Now the link command will make links between files. It will create a hard link by default. Let me demonstrate what a hard link is. This is the original file. I've echoed hello to it, and now I'm going to create a hard link that I'm calling this. So let's link these two files here, and you can see they have the same inode number and the same attributes and the same data. However, if you remove the original file that the hard link made reference to, the hard link will retain the data in the original file. But there are limitations to hard links. So let us try to link this directory to this hard link. It will not work because hard links cannot be made between directories. Let me try to make this other hard link between a kernel file in the boot directory, and I'm going to call the hard link current kernel, and it says invalid cross-device link because hard links cannot cross file system boundaries. That is what symbolic links are there for. Let me clear the screen and let me show you a few ways to make symbolic links. So I'm using the S option for symbolic links. I'm referring to this kernel file, and then I'm calling the symbolic link current kernel. So now I'm going to, let's see if this works. And here we have the current kernel is a file that refers to another file. So let's try this again. I'm going to create a symbolic link and refer to the original file, but I'm not going to put any name for the symbolic link at the end. And now I'm going to list this, and you can see that the symbolic link is named the file name of the original file. Now let me list both of these out. Well, of course, let me list both of these out so you can see them a lot better. Here's the original file in the original directory, and here is our symbolic link that we named, and here's the symbolic link that we did not name. I'm just going to go back to the text, and it's a special file type in which the file will refer to a different file, and the symbolic links characteristically will have different inode numbers than the original file because they are different files. And that's all the material I have for symbolic links. And I hope you enjoyed. Excuse me. The next episode will be about reading environmental variables. So I hope to see you then. Thank you very much.